Oh,
Okay.
yay, not a lot of questions.
Oh, yeah?
And these ones seem pretty, like the whole y equals 2.0, all that kind of stuff. Let's see, I think I have the formula for that.
Oh, let's see if you have the right formula. Mm-hmm. Yeah. Which one do you have, Dustin?
There's been some debate, in other
Yeah.
words.
Let's see if I can find what page I wrote it on. That's one thing about me and note-taking is my notes are so unorganized. I really need to find if they offer a class on how to take organized notes, that'd be sick.
Yeah, I think they do.
Let's see.
Now that you have one semester left.
Yeah. Okay. Here it is. Okay, so it is so y hat equals bo, or what is it? Bo is, I can't remember what it means.
No.
Plus b1 times.
No one's allowed to say BO.
Well, it's not like bo, but it's b naught. That's what it is. B naught.
Yeah.
So
Oh,
b
yeah,
naught
B naught.
plus b1 times x is y hat. So that's the formula we use to get the y-intercept.
Yeah, see, that's different than Brother Balls told us.
Really?
Yeah.
Huh. Well, I got the homework questions right, so it must work.
It must be both.
How could it? That's so weird, because how could it be?
And that's the same formula I think that's in the book, is y hat equals b naught plus b1 times x.
Yeah, that is the formula in the book.
Okay.
Okay, so say that for me again. Why not? I mean, y hat equals.
Y hat equals b naught plus b1 times x. And that's the linear regression formula.
Oh, wait. That's. Okay, that is what I have. It's just. No, it isn't. Oh, it is. You know what it is?
What?
It's just the way I was looking at it. Because order of operations would put the B1 with times X, because the multiplication would have to happen first. So that's,
Oh, I see what you're saying.
yeah. So that does make it the same thing.
Okay, it's just written differently.
Yeah.
I got
No. So,
So we know that, let's see here. So then in this first one, the 2.0, that's the B naught. The B1 is the 1.5. And then, I don't know what the X is. X. Oh, yeah, okay, let's see here.
X is X, right?
Well,
Oh, X.
you can figure out what X is, because like X and Y, let's see here. So Y is 2.
So this one's asking for the y-intercept, which is the B, which is the one that's off by itself, so it's the 2, right?
Uh-huh.
So the B naught, is that the y-intercept?
Yeah.
Yeah. Mm-hmm.
So B naught, then yeah, it's the 2.0.
The 2.0. The next one is the slope, and that's the
B1.
B1.
Mm-hmm.
That's 1.5.
5.
Yes.
And given the linear regression equation, what is the predicted y value of if x is 16? So that's when we do the formula. We do the
Just have to work it.
yeah, we do that 3.0, and then we do that plus the 0.25 times the x, which is 15, right?
Your calculator probably
Or 16.
sorts that out. I have to do mine separate.
So that gives me 7.
That's what I got.
So and then it says make a scatter plot of the math self-efficiency data of the 3 data shapes introduced in the reading. Which shape best describes these data? So does anyone have the SPSS open?
I've got it here.
Okay.
I can get it in my tab.
Open up the data.
Sorry, you guys. You're like, man, he sounds like he's in a hurry.
Is that girlfriend still waiting? Is that the deal?
Yeah, she's in the other room. She's helping me make rope out of natural fibers because that's something I have to do for my survival. I have to make a bunch of about 6 foot of rope out of dogweed.
Oh, wow.
And so I showed her how to break it down, and then hopefully she'll have a bunch of strands ready for me. So good girlfriend if she's willing to do that for me.
Yeah. She's willing to
Then
make
I'll get out there and she'll be sleeping. So one of the. So yeah, we have to get ready for our. We have a 3-day trip next week for our final. So we have to use all the skills we learned.
Oh, cool.
So yeah.
You have to like sleep in a tent that's held up with rope that you made or something?
No, we don't even get a tent. We have to make a shelter using like just clear painter's plastic.
Wow.
And, a mylar blanket, and so it's called a super shelter. So you put the plastic up, you put the mylar blanket at the back of the shelter, and then you build a fire just outside the plastic. And so it creates like a little greenhouse. So it could be like -20 outside, but inside it'll be like 90 degrees.
Wow.
So, but we don't get a sleeping bag. We are making like straw mats to sleep on. We only get to bring like the clothes that we're wearing, and then everything else is stuff that we made in class. So we'll be using like knives that we made out of obsidian or out of bone. We'll be doing a bunch of stuff like that. So yeah, it should be fun.
That's cool.
Okay, so what do I do here on SPSS?
Okay, so do you have the math self-efficiency data?
Yeah, I've got it up here.
Okay.
You want to look at my screen?
Go for it. Okay, you got the view up. So then you go to what is it?
Is it analyze?
Analyze. Then you go to linear. Where is it?
Isn't it under graphs? Too? Aren't we doing a scatter plot?
Oh yeah. So go to graphs. Go down to legacy.
Or scatter plot?
Scatter plot. That's one way of doing it. There's another way too. That's easier, but hit simple scatter, and then you're gonna move the. Let's see here. The score will be the Y. The confidence will be the X. And then go to options. No, that's fine. That's all good. So hit OK, and then double click on the thing, on the picture.
On the thing?
Yeah. You know that thing connected to the thing. Yeah, there you go.
Hot dog or banana, huh? Awfully subjective.
I don't really see any sort of hot dog.
This kind of looks like a peel right here to me.
Hot dog, hamburger, or banana?
It's closer to a hot dog or banana than a hamburger. So
Yeah.
I would say, well, since it's kind of curved at the bottom there, I would say banana. That's just a weird question.
I would say none of the above. But.
I'd say stupid question.
Right?
Yeah.
That's silly. Oh, so I guess we can all make our personal judgment calls on that one, huh? Because
I'll volunteer as tribute, so I'll go with banana and we'll see what it does.
I'm leaning towards banana too.
Really?
Yeah.
Okay, are you gonna go hot dog or banana?
I was thinking hot dog.
I was thinking hot dog too. Okay, hot dog versus banana. Here we go.
But what if it's a big Judd burger?
We can't think too much into it.
I think about food a lot.
Shape of the scatter plot.
I think about food a whole lot.
What can you say about the appropriateness of using sample linear regression model to model this data or these data? So let's see. If the simple linear regression simple linear regression is appropriate.
Why wouldn't it be appropriate? Because it's not linear? It
Well,
seems to be linear.
it kind of is. Oh, let's see. Will you pull up the graph again? I
Yeah, I
mean,
got
it's
it.
all generally going in a direction,
Yeah, I think it's linear.
so it is linear. Um,
So it is appropriate?
so I would think so.
Okay. How many observations? So we just need to look at what it'll give us an n, right?
I believe so.
I'm trying to manipulate your graph there. But we might have to go to that analyze regression, linear regression thing.
Yeah.
Okay.
Regression.
There you go, linear. Independent.
Do I need to change
Options,
anything up
I
here?
think in options you do, no, maybe it's in plots.
Oh, it's in save. You have to
Save?
go to save. Yeah, it's weird. I don't know why, but you go to save.
Oh, there you go, unstandardized under the predicted values.
Uh-huh.
Yeah, under predicted.
Okay. Is that it?
Yeah.
You can also check the unstandardized under is that residuals?
Yeah.
Okay.
Okay. The tutor just told me to do predicted, but that's okay.
Yeah.
So then,
So should be an N there somewhere.
scroll down a little bit more.
And
Yeah,
139.
139.
Okay.
And that's for 8?
Yep.
And sorry, I wasn't paying attention. What did we say for 7?
7
Simple.
was, yeah, the last one.
Okay, it's appropriate. Okay.
So then we need the y-intercept.
Okay.
Here's the confidence data. Okay.
Okay, so you guys just tell me what I need to do.
So
The y is the constant, right?
let's see, the y-intercept.
Is that in here?
No, I think there's a way of, trying to remember.
Wasn't it? Um.
Yeah, you can, you go back to the data file. Let's see.
What's it say on the book?
Let me look. Y-intercept.
The constant is the y-intercept. Did we already say that? So if you go to analyze, regression, and linear, it'll give you the constant, and the constant is the y-intercept.
Okay.
And underneath it is the slope. That's what I wrote down.
Oh, there it is.
Oh, yeah, there we go.
Can you
I
guys see
can't
that?
read that real clearly, though. What is
Here,
it?
let me zoom in real quick. Oh wait, sorry.
Let me do it. So I can read it. What one is it, the top or the bottom?
The top is the y-intercept, and underneath is the slope.
And it's
There it
under.
is.
There, now I can read it. Thanks, David.
Yep.
It's 18.
Under coefficients, right?
Uh-huh.
Is it the B or the? It's the B, right?
Yep.
Yeah, the 18.690.
Uh-huh. That's the y-intercept. And then
Slope then would be the. Boom, boom, boom. 12.695.
Uh-huh.
Yep.
And then what is the predicted y value when x is 4? So then we do that formula with the y-intercept and the slope times 4.
There's a way to do it in SPSS.
Oh yeah,
Yeah, there is.
that way's more accurate too.
Yeah.
Yeah.
Um,
Okay. I remember that much from the tutor last night.
oh, yep, here it is. Analyze, regression, linear, move the independent variable, blah, blah, save predicted values. Okay. So I think
I think it's just in that. In those charts we already made, I think.
Really? Is
Yeah,
it?
Yep,
No,
I
I
think
think,
it seems like you have to type the 4 in some 4, right?
yeah.
that's yeah.
So you have to type the 4 in the
In one of the columns.
in one of the columns.
Yeah, go to the very bottom of the column, and you have to add it in.
And then you have to do that again and it will give you the predicted.
So you have to close whatever the linear regression thing.
Oh,
Yeah, go and then scroll down with the data to the very bottom,
okay.
and then would he put that underscore? Is where he's putting the 4.
Yeah, I think so.
So then yeah, you just put 4 in at the very last column, or scroll up a little. Yeah, so right under where it says 70.
Okay.
Yeah, put 4 there, and
And
then
then,
you redo the thing, and it will fill in the blanks.
okay.
So then if you go back to the data file, and then you scroll down, it should. Hey, it's not there.
But it didn't.
What does the steps say then? Because it should.
To predict the value of y. That's what we're looking for, right?
Yeah, let's see.
Go down at the bottom of the list, after the last row, at the value of x.
So
In the row, in the x column. Did I put that in the x column?
So which one is the dependent? The score is the dependent and the confidence rating is the independent?
okay, so
Is that right?
type the value of x for which you want to predict the y in the cell
that's
after the
why.
row.
Because we put
X column.
I put
So
x on the dependent one instead of the independent.
Seems like it still should have generated a row of some kind, though. We didn't get any.
what's the x?
The x is the rating.
Okay, so put the 4 under the rating, yeah, and then try it.
Hmm.
Still didn't, I think.
It should have done something. Maybe scroll over more, because there's a lot more. Yeah, go to the right. There it is.
There it is.
So the 69.46. Let's see. $9.46935.
Yep. 69.46.
It wants the whole number, so what is the whole number?
69.46935.
But it kept going, didn't it?
Yeah, well, it was really long.
because it says it should be exact, so I think it wants the whole
Oh.
thing.
Oh, how much more?
Well, I don't know if we want the exact because it's got like a billion numbers that I don't think would fit.
Oh, okay, I see.
So I think it's good if we just left it like that, 69.46935.
Um,
Oh.
let's see. Maybe just copy it and paste it on yours and see what it does.
Okay.
That's a good idea.
Yeah, because I think it's going to want the whole number, to be honest.
We can always argue.
Yeah.
It said exact, and we did the whole long number.
Okay, so I guess not, because it won't let you put the whole thing in there. Oh,
Hold
wait,
on.
it didn't even copy the number.
Yeah, that was weird. Oh, hold on. I think it won't let me because this is technically a different screen.
Oh,
So
yeah,
when
you're
you
on
copy,
SPSS.
since I copied, it's only letting me copy and paste in this thing.
That's true.
Well, that's
Well, if
like,
you leave that screen open, I could just type it all in.
Okay. You ready?
Yeah, I'm gonna, let's see here. I gotta make my window smaller so I can do it. Okay. So 6945319978352
Yep.
All right.
Does
Can you
it
read
fit?
that off one more time?
Yeah, it fits at 69.469.
Point four six.
351.
Oh, sorry.
Oh, sorry.
Start
So
again.
69
Uh-huh.
46935199783526.
Thank you.
Yep. So then,
Confidence data.
Results
Is this still part of this?
I
Yeah.
think so.
The 13.
Results
Confidence.
from students and
so the confidence interval. This is where we use that old school formula for confidence interval.
Are you sure? Because there is a positive correlation, we can use the largest x value to find the largest predicted value of y. What
Oh
is the
wait, no.
maximum predicted value of y for these values of x?
No, okay.
It's got me stumped there. I have no idea. Oh, wait a minute. I think I see something. Down here where it says residuals statistics. Hold on, let me enlarge that real quick. Can you see that?
yeah.
It says right there maximum predicted value. What do you guys think?
Sure. I don't even really know what this question is asking.
I mean, I can't think of anything else. predictions.
Find the largest predicted value of y. I want to say that we did a question with this. Let's see.
Yeah, I don't see anything.
The largest prediction of y.
Okay, so there's pictures of hot dog shape, hamburger shape, and banana shape in the textbook.
Really?
Going back to the other one.
Oh, yeah. Yep, so we would have been right.
See, it's hot dog shaped.
Okay.
Yeah, I'm going to go with what I'll volunteer as tribute as far as this maximum thing goes. I just don't know if it would be predicted value or the residual value.
I'm gonna say it's probably the predicted because it's saying what
Yeah,
is
the
the
predicted
maximum
value for maximum.
value.
Okay, well, it's 94.86.
Okay.
And then if I get it wrong, then you guys can figure out what happens.
Alright, so then we have how many explanatory independent failures are present in the sample linear regression.
In simple, linear. Present in simple. Wouldn't it just be one?
That's what I'm thinking.
If it's linear, it's one for one, right? Variables.
Well, it says, so, what does it say again? How many variables, how many, so I think there's
Oh,
two because there's an independent and a dependent. So X is the independent, Y is the dependent, right? Because if it's just
So
one,
there's,
then it would just be, it wouldn't be
so,
linear.
oh wait, so would it be two for the independent and one for the dependent?
Um, I would,
See, look right here in the textbook. It says this provides a powerful tool to model bivariate data involving two variables. The only reason why I would say 2 for the x is because of the b null and the b1,
oh yeah, those are both Y, huh?
or is that y? Are
No,
those
no,
two?
the B naught is the Y, and then the B1 is the X axis.
Oh.
So that's why I was thinking there's two. So let's see.
You guys on 13 and 14?
Yeah.
Yes.
Oh
It's
wait.
one
What?
for.
What did you say?
I think it's one for each, and I think he was saying that next lesson we're going to be learning about when there's more than just one.
Oh wait, here it
Oh.
goes. It says, let's see, in the number 2, it says a simple linear regression method used to fit a line to data. This provides a powerful tool to model whatever data, i.e. the data involving two variables. So,
So there's
But it
the
doesn't.
independent variable and the dependent variable.
yeah.
Yeah. So it's just 1 and 1, right?
Yeah, so it's 2.
What did you guys end up figuring for 12 when my internet died again?
94.86.
94.86. And
But we're not 100% sure on that. So
Yeah, I'm gonna volunteer as tribute for that. But so 13 and 14 is 1, right?
13 is 2.
13 is 2?
Yeah, it says how many explanatory independent. Oh wait, how many independent variables? So that's right, that's 1. And then
Mhm.
how
One
many
independent
dependent?
and one dependent.
Yeah, I was reading it as them both together. So okay, so yeah, it's 1 and 1.
Oh, and Tara, there's pictures of the hot dog and hamburger and banana
Oh, yay! In the book,
in the book.
Yeah. So we were
Okay.
wrong. It's actually a hot dog.
is it?
All right. So everything is correct except for I got number 5 wrong.
5.
Which I put 2.7. Was that wrong?
I put 7.
I
Oh,
put
whoops.
That was
Oops,
probably just a slip of the finger.
Whoops, sorry. That was probably a mess up there. So there was probably just a typo. So, yep, everything's right.
No, wait, don't do it yet. I got it wrong for just putting 7 too. So it's not just 7.
It's not 7 either.
No.
Oh,
Which I thought, because it says use the linear regression, so you do, let's see.
Oh, because it's -3.
oh
Ah!
little
That's
tricky
why.
dash.
Tricky, tricky. Okay. So yeah, we
Okay.
can do it with that as -3 and see what happens. Let's see. So clear. -3 plus 0.25 times 16.
That would
That
be
gives me 1.
1.
So
I got -12.
You
no,
got,
it's, I got 1.
1.
In the mouth are 2 or 3 witnesses.
But I
Alrighty.
only get my own singular witness on the test. Gosh darn it.
So, all right.
Well, now we know that on SPSS it is that part. It's this thing, maximum predicted value. So,
That
All right.
alrighty.
Good job, everybody.